Assalamu alaikum students. Today we will start with the paper 6 third variant of October number 2025. Question number 1. A student uses the apparatus in figure 1.1 to show that water is one of the products. When a fuel is burned, the gases produced when the fuel is burned are passed through the apparatus using a suction pump. So this is the diagram of the apparatus. Identify the item of the apparatus labeled W. So we can see that this is a Y shaped, but it is inverted. So this is basically the inverted piece of the conical funnel. This is conical funnel which has been inverted. So you can write here conical funnel, or just funnel is also correct. Then B part. When the fuel is burned, the steam produced passes into the U-tube, suggests why the U-tube is surrounded by the ice. So you can see the fuel is being burned in this part, and the gases will be escaping out of this area into this delivery tube, and then it reaches to the U-tube, and this U-tube has a lot of ice surrounding. So basically, we must understand that when a fuel is burned, it will be releasing some sort of vapors or gases, or it could be a steam. It could be any one of these things, because we do not know actually the which kind of fuel is being used here, but some fuels are definitely the hydrocarbons, and hydrocarbons when burned, they produces carbon dioxide plus water. So like water will be in gaseous state, that is called steam. So when the steam will pass through this U-tube, it will be condensed into the liquid form. This solid, we do not actually know what is the identity of this solid because of the presence of the unknown fuel. Some fuel would have been producing the gaseous state of the solid products in this part, and then that condense, or you can say that convert some gases to the solid state directly. Anyways, what we can say about here, the steam produced passing into U-tube. So if they are clearly stating the steam is being produced, so that steam is condensing. Steam condenses to liquid. So this is the purpose of using the uh, to use the ice to liquid, and you can also write water to liquid water. And see, water causes solid X in the U-tube to change color. Name the solid X and state the color change seen. Okay, so this solid X that is present over here, it interacts with the water that has been produced by the condensation in the previous part. So which kind of the solid that you have studied in the syllabus changes the color upon interacting with the water? If you could recall from the knowledge, from the literature. So if I take you to my notes, we studied in this chapter of equilibria, where the cobalt chloride paper was used. This cobalt chloride paper, which is basically a blue color and actually it's blue color in the anhydrous form. So anhydrous form of cobalt chloride is blue, and the hydrated form is pink in color. So this is one solid that can be used here. The other one is a copper sulfate. So copper sulfate can also give you the different colors in the form of the anhydrous. It is white in solid, and in hydrated form it is blue. So you have choice. You can mention any one of these two, whether the copper sulfate or the cobalt chloride paper, cobalt chloride solid. The solid X can be anhydrous, and it says name solid. It means you do not need to write the symbol. Rather, you will have to write the name of the solid. So anhydrous cobalt 2 chloride or anhydrous copper sulfate, copper 2 sulfate to be more precise. Now, if it is a cobalt chloride, the color changes from blue to pink, and for the copper sulfate, it is from white to blue. These colors belong to the anhydrous state, and these belong to the hydrated state of these named compounds. The next part, the student tries to use the apparatus in figure 1.2 to pass the gas produced through acidified potassium manganate. There is an error in the apparatus in figure 1.2 so that the gases produced will not pass through the acidified potassium manganate. 7. So this is the apparatus in which again fuel is being burned, the gases will released, they will pass through the delivery tube into this. Now this one is a kind of a tube. This is a tube. Identify the item of the apparatus labeled Y. So although it's a tube, but because of the reason that we are applying a temperature here, if we are applying a temperature or anything like a heat source is being applied, always remember that we must be using the boiling tube in this kind of a experiment. So this is a boiling tube. Then E part, on figure 1.2, draw a circle around the error in the apparatus. Now, if we see from here, the gases are being released by the burning of the fuel. They will go like this into the delivery tube, and then they will reach the boiling tube. The purpose of using the potassium manganate, if you can recall, and the qualitative notes, we had said that it was basically used to give its own color when it interacts with a one kind of the gas. This is a gas which is used here to check the presence, to check the identity. SO2 gas changes the color of potassium manganate from purple to colorless. So the SO2 gas must be coming in touch or in contact with the potassium manganate solution. But in our case of the experiment, if you look closely, the gas, if released from here, has option of going upward as well. Like it will be saturated, the gas will be saturated in this whole area, and it can also go upward. However, the level of the liquid is just below the mouth of the test tube. This is a level liquid, but this is the level of the test tube mouth. So there is a problem here. The gas may not come in contact with the liquid completely. Rather, the gas can go even in the upward direction. So this is a kind of the error here. We must indicate the area that is an error in this experiment, in this apparatus or this setup. So we can say this is the error. We represent the error by encircling it. So this is the error, that it is not in contact with the level of the liquid. We are supposed to draw a circle. So we have pointed out clearly and correctly where the error is. Then F part, the error in the apparatus in figure 1.2 is corrected. The student observes that the acidified aquapressure manganese changes color from purple to colorless. Suggest why this color change occurs. So to understand this point, we must go to the qualitative notes and see the gas was SO2, which changed the color from purple to colorless. So what we can infer about this, that why this color change occurred? Because the gas that was produced was SO2. SO2 gas was produced. SO2 gas was produced during the experiment or when the fuel was burned. I hope it's clear to everyone.
Yes, sir.
All right. Then question 2. A student investigates the temperature change when a 5 centimeter length of coiled magnesium ribbon reacts with excess dilute sulfuric acid. The student does 5 experiments. You all have the workbooks in the hard form. You can go through these lines by yourself because there are so many lines that will take you time to read. So I'm jumping straight to the question. Part A, use the thermometer diagrams to complete the table 2.1. So here we have the whole table in which we have to properly write down the readings on the table. So I'm gonna do that now. We have 21.0 degrees centigrade here. You don't need to put signs of centigrade because it's already there in the title, so you don't need that. Okay, then for the next case, it is 21.5. If I take it closer, it is in between these two lines, this one and this one. It is in between these two, that is, it is 21.5 degree. Then next, we have 20.5. It is again 21.5, yeah. It is again 21.5 because these are the initial temperature, mind it. Initial temperature of the experiment. That's why the values will not be varying that much. They will be consistent almost. Now this time it is 22 degree, 22.0. You need to put a 1 decimal point after the value. Then fifth value is 22 again, 22.0. That's it. Now coming to the final temperature. Now these can change because for every experiment you are basically using a different volume of the sulfuric acid. That's why the volume of the final temperature will be varied every time. Now here we have 29.0. This one is 36.5. This one is 33, in between 33 and 34. So 33.5. This is between 38 and 39. So 38.5. This one is 46. So we have correctly written the values. Now the last table belongs to the temperature increase. Temperature increase is simply the difference. If I say this is Ti, initial temperature, this is Tf, final temperature, then temperature increase is basically delta T. If you are familiar with this symbol, delta, which shows the difference of two values. It shows a difference. So difference will be between final temperature and initial. We will write it Tf minus Ti. Final temperature minus initial temperature. So for the first case, it is 29 minus 21. So it is equal to 8.0 degree. And next one is 36.5 minus 21.5. So it is equivalent to 15. And next 33.5 minus 21.5 is 12. Next is 38.5 minus 22, 16.5. And this one is 44, 24. Okay, so these are the values. We need to put zeros as well along with the values, which are whole numbers. Say 24.0. If you forget to put a decimal point, you will lose a mark. Even 1 mark can be lost if you do not put a single decimal point after the values. So be very careful while you are writing. In fact, I made a slight mistake here as well. So 46.0. I have to look at all the values over and again to see if I'm making any mistake or not. So do the same whenever you are doing in your actual CA exam. Now B part. On figure 2.1, complete a suitable scale on the y-axis and plot the results from the experiment 1 to 5. Draw a line best fit. So you have the values. You need to put them. Along the y-axis is temperature increase. Along the axis is the volume. So volumes were already given over here. We had 10 till 30 cm3, so we do not need to worry about it. We need to put the values for the temperature increase. So I'm just gonna put the points on the vertical side, and then I will match them along the x-axis. So first we had the 8 degree that belong to the volume of 38. So we need to understand the graph, the values as well along the y-axis. If it is 0, this will be 10, 20, 30, 40, and so on. So 8 lies over here, 8 degree. This is for 8. Then is 15 degrees. So this is 10, 11, 12, 13, 14, 15. This is 15. Then 21. Then we have the 12. So 12. This one is 12. then 16.5, that comes over here, and 24. 24 is, this is 20, this is 24. I need to put them correctly now on the given volumes of the sulfuric acid starting from the 30 cm cube. We were provided with 30 cm cube in the first case. So 30 cm cube with 8 value. The next one was 15. So this is 15 with volume of, okay, we had the volume of 30 cm cube initially. 30 cm cube. And then for the value of 15, we had a volume of 25 cm cube. And next 12.0. So 12.0 is over here with 20 cm cube. And then 16.5 with 15 degree. And last we have 24 degree with 10 cm cube, that's already placed over here. Now you can see the values are like this. Okay, now on figure computer suitable scale, revise and plot the results from the experiment to draw a line of best fit. So line of best fit has to be drawn here. So how we can do this? I will just use a rough way to plot a line of best fit. That means go from the center of the values from here. Now this is just a rough value, rough line. You can use a scale to properly construct the line of best fit. Then we have explained why the temperature increase changes as the volume of the dilute sulfuric acid changes. So you can see over here that as we increase the volume of the acid from 10 to 30 cm cube, the temperature increase was decreasing. Temperature increase was less when we increase the volume of the sulfuric acid. Now why is that same? Why this happens? We can say that the temperature or the amount of the heat energy is the same. The amount of heat energy it crashed. Anyways, we'll try to complete it somehow. Amount of heat energy is same even when the larger amount of even when the larger volume of acid was used. So if you are using volume, let's suppose from 10 cm cube till 30 cm cube, the amount of heat energy is same. Why is that same? Because the magnesium ribbon used is same. However, the acid was already in excess in all the cases. In all the experiment, acid was in excess. And magnesium ribbon used was also same in length. We used this much length of the magnesium ribbon. If we go back here, they were using 5 cm length. It is the length, and at the same time it's the amount of the magnesium element. So both are same, and sulfuric acid is already excess in all the experiments. However, the volume has been changed from 10 cm cube till 30 cm cube. So that's why the temperature rise was less, even when larger amount of the acid was used. I hope it's clear to everyone. Then D part say extrapolate the line of best fit on your graph in figure 2.1 to deduce the temperature increase if the 33 cm cube of dilute sulfuric acid is used. Unfortunately, the values were gone, but I will try to reconstruct it quickly. So 8 degree was there for 30 cm cube, then 15 degree for 25, and then we had 12.0 for 20, and then we had 16.5 for 15, and at the last it was 24 for the 10 cm cube. So the line of best fit is something like this. Okay, now we have to we are supposed to extend the line to reduce the temperature increase if 33 cm cube sulfuric acid is used. 33. So over here, this is 30, 31, 32, and 33. So I have to extend line till just a little more than 33. So this is 33, and this is the point at which the temperature lies. So we need to find that temperature. This comes, temperature rise is over here. It is 4 degree rise. Temperature increase is 4.0 degree. You need to put the correct unit along with the value. Then E part, the investigation is repeated using 2.5 centimeter length of the coiled magnesium ribbon instead of 5 centimeter lengths. On figure 2.1, sketch a line to show the result you would expect. Label this line E. So as I said before, and I showed you that previously or initially we were using 5 centimeter length. That is also the mass, not 5 gram. You cannot say it's a 5 gram, but 5 centimeter length will definitely have some specified amount of the mass, some specific mass of magnesium. And if you use 2.5 centimeter length, it will definitely have almost half mass, almost half of initial mass which we used previously. So if you are decreasing the amount or the mass of the magnesium, you are basically also decreasing the temperature release. Since the reaction is between the magnesium ribbon and the acid used is sulfuric acid here. we are using sulfuric acid to react with the magnesium. So definitely the reaction will be Mg plus H2SO4 to produce MgSO4 plus H2 gas. So there is that experiment to investigate the temperature change which we are doing. So if you are decreasing the amount of the magnesium, if magnesium mass is decreased, then definitely temperature rise will also be lessened. Less temperature of the experiment will be observed since mass of Mg is less. Now we need to show that lessened temperature rise in the figure of graph. So temperature rise will be lowered and we can somehow say it will be below the already plotted line. I will say it can be somewhere. There is no exact point where, but it will be lowered. You can plot from anywhere here. I'll plot something like this. It will go straight in the same direction as previously. However, do not drop it to the 0 degree because the mass is not 0 gram. This 2.5 centimeter would have some specified amount of the mass, so the temperature release will be there. It will not be 0. So keep it above the axis of x. Keep it above the 0 degree. So this is okay, and then you have to label E. It also asks you what to do. Sketch a line. Label this line E. You have to do the same because I'm doing on my screen with a different color. But when you'll be doing on the paper, you will have the pencil to sketch the line. So the examiner would not know which of the line is a new one. So just label it E. The next is F part 1. Give one reason why burette rather than measuring standard is used to measure the volume of valeric acid. We already know that. We have been doing these questions again and again to increase accuracy. To increase accuracy. Then second part, explain why the contents of the boring tube are stirred during each experiment. So when the sulfuric acid was being added into the boiling tube, and the boiling tube had the 5 centimeter length of magnesium or maybe 2 centimeter, it was supposed to be stirred during that addition. It said continually stir the contents of the boiling tube using the thermometer. The thermometer is placed inside the boiling tube, and this is the picture. In the first case, okay, boiling tube. This is the boiling tube, but the new type of the experiment is slightly different. We are also putting. We have also dipped a thermometer. Just consider this is some sort of a thermometer which is dipped into the boiling tube. It has measurements of temperature on it. Just imagine something like this. So this thermometer is not only noting the temperature. This is not only noting the temperature, recording the temperature, but also helpful to steer it. Like you can hold the thermometer by your hand over here. Just grab the thermometer from this point and steer it. Steering is also done along with the thermometer. Both functions are being done using a thermometer. Now, why are we steering it? Since we are mixing two things, the magnesium ribbon and the sulfuric acid. So mixing must be thoroughly done to mix evenly. To mix evenly or to have even distribution of the heat. Even distribution of heat, because heat is also being produced, and if the liquid is a large amount of acid is there in the burning tube, the heat energy might not be evenly distributed if you do not stir it. So stirring helps to evenly distribute the heat. The G part: describe one chain to the apparatus that will give more accurate result. Explain your answer. So if we go back to the procedure of the experiment, we saw that the burette was being used to add acid into the boiling tube, and then the thermometer was also dipped into the boiling tube along with noting the temperature, and a coil of the mixture ribbon was also added into the boiling tube. So what the boiling tube is working like? It's working like a beaker in which magnesium ribbon is there, in which H2SO4 is there, in which a thermometer is placed. So all the things are there. So isn't it possible that during the mixing and stirring of sulfuric acid and magnesium, some heat energy will also be escaping out or wasting from the same boiling tube? Just consider this is a boiling tube, but it is open. Since we are constantly uh, using the thermometer inside of it, we are adding acid and the magnesium ribbon, so it is not closed end, it is basically open end. So being an open end of the boiling tube, there is a very strong chances, there are very high chances the heat energy will also be dissipated. It will be wasted. In a sense, heat is wasted, it is lost, heat is lost. So what can we do here? How can we prevent that problem here? We can simply uh, insulate the boiling tube. We would insulate the boiling tube. Why? To reduce or lessen the heat loss. That's why we are doing this. So we have completed 2 questions of this paper of October number 2025, third variant. The remaining 2 questions will be sent to you in the recorded form. So you can do them, you can watch them in the later time. So if you have any question till now, please let me know. So students, that's all for today. We will continue this paper in our next class. Till then, take care and Allah Hafiz everyone.